Hey there. So in this video we will set up our workspace in IntelliJ IDEA, and to do that I have already created a Git repository which you can simply clone and open it in IntelliJ, and from there it automatically bootstrap it. So to do that, head back to your browser, type github.com/vslala. This is my repository section in GitHub. Click on the repository tab, go to code with Varun, and then click on this green button here. This will give you a link which you can copy, and once you have copied it, head back to your terminal and type git clone and then paste that link here. So what it will do is it will create a folder with code with the Varun name, that is the default repository name, and inside that you will see these files. So I have already cloned it before, so that is why you're seeing it here. And the benefit of this is that you already have the Gradle file with you. All you have to do is open it in IDE. So for that, so if you have this idea set on your class path, it will automatically open that workspace in your IntelliJ and set up the workspace there like this. So here you can see that IntelliJ detected this build.gradle file, and based on that it created all the necessary folder structures for you. So now it's all set. You can just start coding in. See you in the next video. Hey there. So just to give you a little context about what I'm doing, why I'm doing it. So for some time I'm into web development a lot, and I miss this part of computer science. You see, the algorithms and the world of computer science basically. So I used to do it back in college, and it's been a long time I have not revisited it. So I thought it's a good time for me to revisit all those concepts. So I thought of doing it myself, but it's not that fun. I have done it before individually, so this time I wanted to share what I do. So that's why I'm recording these videos, and I don't expect to gain audience through this, but it's just my way to project this out to the world so that other people who are trying to learn the same thing can gain some help, or maybe possibly a guidance if you can. So yeah, so I'm thinking of starting with the selection sort. That's the easiest, I think, after bubble sort, and I've already done bubble sort. So yeah, let's see how selection sort works. So as you can see on the computer screen, I have this visualizer open. I've set the parameters like array size is 8, layout is array, and I'm going to run it. So as I remember, the selection sort from the name says that you have to select the, let's say if we are sorting the array in ascending order, so you have to select the biggest number in the given array and then move it to the end, and then repeat the process again and again. So let's see how it works. So yeah, we'll start with the at index, and we will find the next biggest number in the array, and it is 682. So great, then we reset it to 682, then we search a number which is even bigger than this number, because we are in the first iteration, and first iteration will go till the end, so we will find the biggest number eventually. Cool. So 916, then we'll compare it with 983, and great, we'll see, okay, 983 is the biggest, and also it is in the right place, so we won't do anything here. Cool. So in the next iteration we'll again start with the 0th index, find the next biggest number, then the next biggest number, then swap it from the last index. Cool. So this is what we have to do. So I'll head back to the IDE and do some coding. So now we'll start coding selection sort. But before that, in this video I want to cover not just the selection sort but also TDD. So if you're not familiar with TDD, well, TDD stands for test driven development, and it has become the industry standard. So if you're going to work in any enterprise, this is going to be there. You will have to write code, like test code, then you will go and write the actual code. So if you don't understand what I'm talking right now, so just bear with me for 1 minute and I will tell you what it is. So this is the workspace that we set up in the previous video, and so now we'll go ahead and create a class, and before that let's create a package and call it sort, because we are going to have more sorting algorithms in future. That's why we are going to put it all in this package. So cool. So once you have this package set up, sorry for that, we'll go forward and create a class called selection sort, because that is what we are doing. So now I won't start coding right away. In TDD, you have to create a test class first, and you have to write a test for the functionality that you're about to implement, and then you implement that functionality. So what happens is that it helps you to think about the objective before even implementing it. So let me show you how it is done. So we'll create a test class. So if you're on Mac, you can press Command Shift T, and if you're on Windows, I think Control Shift T would give you this option. Then press Enter. Yes, I want to keep my test class name as selection sort test. Click OK, and you see that IntelliJ is really smart. So it knows that you're creating a test class for your selection sort. So it automatically gave the option to put that file in a test directory with the same package. So all you have to do is click OK. Now, every test, or you can say every programmer follows a kind of structure to structure that code, structure their test cases. So I'll be following pretty standard structure here, in which we will start with the setup, then we'll write the test cases for each, and then we'll clean the objects that we have created. So to set up, I make use of before each annotation that comes with the JUnit 5. So yeah, so setup, what do you want to set up basically? So what we are testing is selection sort. So we want to create an object of this class selection sort. So before each, as name suggests, it runs before each test in your test suite. So we are going to have multiple tests in this class, or this very trivial functionality will just have one. So yeah, usually you have n number of test cases in a given suite, and before running each test case, it runs the setup step again. And you have to clean as well. This is good practice. We don't have to do it in this particular example. It's not very useful here, but it's a good practice, I would say, to clean up your mess so that it doesn't interfere with some other test cases or change the state or affect the state in any way. So call it cleanup, and I'll just set it to null. It's not required here, but I'm just doing it to show you how it can be done. So before each will run before every test, after each will run after the completion of the test. Now we'll create the actual test case for this. It should sort the given array in ascending order. So again, so coming to this function method naming convention in test cases, I like it to be very elaborate, so that if you're going to read my test case, you'll automatically get a documentation of that particular class which is being tested. There are other conventions as well that people follow, like given, when, then. So they would say like given a unsorted array, when this function is called, it should give us a sorted array back. So people do all sorts of things, but yeah, these are the two standard way of doing it, I think. So I follow this convention. I find it easier to understand when I look back to the classes. Cool. So once you have this method set up here, Now you have to start thinking like what you want to test and how you want to test it. In this case, we are going to test a selection sort class. The whole purpose of this class is to take an input array, sort it in ascending order, and then return that sorted array back. So this is what we are going to test here. So remember, we don't have any code right now, but we are just assuming that this class should have so and so methods. It would take so and so input and give us so and so output. And based on that, we'll just write the test case. So we'll have an input array, or we call it array. This is going to be an integer array of, I'll just put the random numbers here, not thinking at all about anything. Cool. Now once I have this input here, I want to call the sort method of my testing class, the class which I'm testing, because I want to have a sort method inside that class that will take this array as an input parameter and will give me a output array. Output array is going to be of type integer array. Let's call it output for now. And now the third step is, so the body goes like this: given when I call this method, then what should happen? Then I should get a sorted array. So this my output array is a sorted array. So okay, so I'll iterate over it, int stream, right, and range. Yep. So length -1 for each index. I have to see that. Let me type it real quick, then I can explain it. It's less than output index +1. Cool. So this is what we are going to assert, and this should be true. Actually, we don't even need this. Yep. So in this statement, I'm asserting that whatever output array I have, it is sorted. In fact, it's not like it's not sorted, it just gave me some wrong input. I have to validate. I have to see that whatever output that I'm getting from that method is sorted or not. And finally, we'll generate this method. And if you have noticed, I have not written any code so far in this class. Everything is done via IDE, and that is what you want to do. You want to make use of your IDE at the most. So now I'll only write the logic that I have to implement, and all the boilerplate code like the method and the return type and all of this thing should be generated from your IDE. That's the entire, thought process behind test-driven development. Cool. So now we can simply write the logic. Yeah, but before going that, I can run this test and it should fail now. Why did it pass? It shouldn't pass, it should fail. Because this array is not sorted. And what is it returning? Ah, that's why it passed. I'll return the array for now. Cool. So now it is fading. So actually, I also found that one thing. I also have to assert the length of the array that I'm getting back, because the first time we ran this code, it worked, so it shouldn't happen. It means that it was a faulty test case or a missing assert statement. So I'll say the input or the array that I'm passing, its length should be same as the length of the array that I'm getting back. So even though if I don't change the code here, it should fail. Great, saying that the length do not match. So this seems to be a complete test case now, and if we encounter any missing scenarios, we should add it right there. And then cool, so I'll see you in the next video where we will code the actual logic for this method. See ya. Hey, welcome back. So far we have written one test case. So we have completed a small milestone. So whenever we complete a small milestone, we should come back here and commit our changes to Git. And that is what I've done here. So I added all of the changes that I had. So we only created 2 classes and made some changes in there. So there was no change diff as such because we are starting from scratch. We don't have an existing file. So it was showing that, okay, I created a new folder or the classes inside those folders. So I added all the classes. I commit change with a message. Here's another important bit. So whenever you're working in an enterprise, there are more than one developers, obviously. So every team follows a convention. For example, in my previous project, we were following the convention, like we were prepending the commit message with the user story card number, so that the person who is looking at the commit will know, okay, this particular feature belongs to that particular card, which was covered in so and so date and time. And similarly, if you're code pairing with someone, you tend to mention both the programmer's name. So, but here I'm only working on this, so I have mentioned my name here, and you can do it any way you want. Like people do a square bracket, they do curly braces, and so it depends. It really depends on the team and the structure that they're following. And then I prefer to write everything in the assertive manner, on the present tense, like add a test case for selection sort. So it's like more commanding. So if you're going back in the history, commit history, and you're reading all those commits, it tends to make more sense. Automatically, you will see after a period of time, once you're used to it. So if you write assertive commit messages, I think it is more understandable when we are going through the commit history log. And then, yep, I have made the commit. Cool. So let's head back to our selection sort method. Now we have to write the algorithm. So if you remember from the visualization bit that we saw, that, okay, in each iteration, we pick the max number and then swap it, like push it till at the end index. So that is what I'm going to do. So let's do it a little bit differently. Let's create a variable called last index, and this is going to be the length -1. So if my array length is 4, then the last index is going to be 3. So while last index is greater than -1, so I'm shrinking from behind. Now for each of this, I need j to start iterating from 0 till it is less than the last index, because I don't have to check the last index as such, because I know that it is already sorted. For now, let's visit till the last index, and then we'll see j++. So if max is smaller than j, then max is equals to j. So I'm just maintaining the index number. I'm not doing any actual value swap here. You might have seen in other implementation that they do swap at every comparison, but I'm not going to do it here. I'm just going to maintain the index, and at the end I'm just going to put it back, like put it at the end. That is why we have that last index variable. Cool. So this max should be set to, it doesn't matter, I just set it to 0 every time, and we can always start from the index after that, because comparing 0 with 0 doesn't make any sense. Cool. So far so good. So once this, at the end of this iteration, we should have a max index. So let's swap the values present in those. This is the last index, then at the last index I have to put the value which is there in the max, and at the max I have to put the value which is there in the last temp. Now this should sort the array. Okay, it never works first time. Oh, okay, it's showing the error. I have to decrement it. Good call. Benefits of having IDE. Okay, yeah, so I was telling you, like, it never works for me for the first time. It always gives some kind of error. I have missed the test case, I've written it badly, or some more other issue. So let's see. I'm not very hopeful it will run in the first one. Exactly. So we are getting an assertion error in this statement. Okay. Okay, so if you find something like this, like you don't know what the output is, it's better to print the output and see what it is actually returning. So I'll do arrays.stream output, then map to object string. I'll convert integer to string, then collect using this. So it will print the print all the elements in the array. Let's see what we are getting back. 3, 7, 12, 23. Hey, it's sorted. It means that the test case will be alrighty. We're not comparing the case where both the elements are same. For example, 23, 23. If we are not putting this equal to sign here, it will return false. Great. Now it should turn green. Yay. So our selection sort is working as expected. Just a quick replay, or what we can say. Yeah, the replay of what we have done so far. We maintain the last index because, as you saw in the visualization, let's go back if I have that already open here. Yep. So here, so what I'm doing is I'm maintaining the last index. So for example, in this array, let's shorten the array. Do we have any? Yep. So let's say the last index is 215 to start with. Like the length of the array is 5. We have set last index to length minus 1, which is 4. So our last index is 4. And once we run the iteration, the first iteration, we find the maximum, the biggest number, then we go till the end, then we swap it with the last index. Now last index should reduce by 1. So now my last index will be 3. Then I'll start again from the start. So as you can see in the code here, I've set max to 0, and then j starts from 1, and they compare like max and j. So my j is at 1, index 1, and the max index that I've set is 0. So 0 will compare to 1. Obviously 0 is smaller, so we set the new max index to be 1. Then compare to the next element, j, because j increments every time. J increments every time. Then again we found that, okay, we found a bigger number than what we had before. We change, we assign a new index to the max variable. Cool. So our last index was 3 because we reduced it by 1, and we are reducing it by 1 after every iteration. So we can swap it like that. So at the end we have a sorted array. So far so good. I still have got that touch. Nice. Cool. So see you in the next video. We will cover another algorithm. Let's see what comes after selection sort. Insertion sort. So we'll cover insertion sort in the next video. See you. Bye bye. Take care.